In this video, I'd like to show you some examples of linear inequality problems. There are 4 different inequality symbols, and its word expression you need to know. You should also be aware of how they are represented on a number line as shown. Like linear equations, inequalities can be solved by applying similar rules and steps with a few exceptions. The only difference when solving linear equations is when it involves multiplication or division by a negative number. Multiplying or dividing an inequality by a negative number changes the direction of inequality symbol. Let's take a look at some examples for solving inequalities, starting with the simplest problem. Just like solving equations, we add 8 on both sides to cancel negative 8, and we are left with 2x less than 14. Now we divide both sides by 2 to isolate x on the left side, so that we have the final answer as shown, as well as the interval notation. Please note that the opening small round bracket means that the right end point 7 is not included on the interval. This is a graphical representation of the solution. Let's take another example. We first collect the x terms on the left side and constant on the right side to get negative 3x is less than or equal to negative 12. Next, we divide both sides by negative 3 to isolate the x on the left side. Since we divided both sides by a negative number, make sure to change the direction of inequality symbol. We have the final answer as shown, as well as in interval notation. Please note that the opening square bracket means that the left endpoint 4 is included on the interval. This is a graphical representation of the solution. Next, we will explore examples of double or compound inequality. There are 2 methods to solve this type of problems. The first method involves solving all 3 parts at the same time, and the other method is solving 2 separate parts independently. Let's try to solve a double inequality problem using the first method. To begin, we subtract 9 from all 3 parts to isolate the x term in the center. We have the result as shown. Then, let's go ahead to divide all 3 parts by the coefficient of x, negative 1, to make it so that we just have x in the center. Again, since we divided by negative number, we need to change the direction of each inequality symbol. We now have the final answer as shown. Again, this is a graphical representation of our solution. Let's try to solve a double inequality problem using the second method this time. First, let's make 2 inequalities according to the rule. Starting with the first one, we collect x terms on the left side and constant on the right side to get negative 3x is less than or equal to 6. We then divide both sides by negative 3 to isolate the x on the left side. Since we divided both sides by negative number, we need to remember to change the direction of inequality symbol. The answer from first inequality is as shown. We need to set this aside for now and solve the second one. As before, we collect x terms on the left side and constant on the right side to get 8x is less than 4. Then divide both sides by 8 to get the result as shown. Combine the two results to get the final answer as shown. Once again, this diagram represents our solution graphically. Lastly, let's take a look at inequality cases involving absolute values. Case 1. Absolute value of x is less than or equal to some number case is shown. Case 2. Absolute value of x is greater than or equal to some number case. Case 3. The absolute value of x is less than or equal to some negative number case. Since the absolute value can never be negative, there is no solution in this scenario. Case 4. The absolute value of x is greater than or equal to some negative number case. Since the absolute value is always greater than 0, all real numbers can be in this range. Now let's apply what we have learned using some examples for absolute value inequalities. What we have here is an example of the first case. The absolute value of x minus 7 should be less than 9. The absolute value refers to the distance from 0, so the distance should be 9 units to the left or 9 units to the right. Therefore, the inside expression of the absolute value symbol must be between negative 9 and positive 9. We add 7 to all three parts to isolate the x term in the center. Then we have the solution as shown as well as its graphical representation. Let's check to see if our solution is correct or not. Pick a value between negative 2 and 16, say x equals 0. Substitute x equals 0 into the left-hand side of the inequality, and we get 7, which is indeed less than 9. This test value satisfies the inequality. This is an example of the second case. According to the rule, let's make two inequalities. For the first one, we write the original problem without the absolute value symbol. Another one should be less than or equal to negative 15. Notice that this one has an opposite direction of the inequality symbol with negative number. Please note that if this is a greater than symbol, then it must be OR situation. Let's go ahead to solve the problem. We add 1 on both sides to get 2x is less than or equal to negative 14. Now we need to divide both sides by 2. So the first answer is x is less than or equal to negative 7. Now let's get the second answer. Once again, we add 1 on both sides to get 2x is greater than or equal to 16. Then we divide both sides by 2 to get x is greater than or equal to 8. The final answer is shown as two regions, as well as its graphical representation. Please note that OR indicate the union of two answers. Again, let's check to see if our solution is correct or not, just in case. Pick a value less than or equal to negative 7. Say x equal to negative 10. Substitute x equal negative 10 into the left-hand side of the inequality, and we get 21, which is indeed greater than 15. Let's pick a value from the other region, say positive 10 this time. Substitute x equal 10 into the left-hand side of the inequality, and we get 19, which is indeed greater than 15 as well. Both test values satisfy the inequality. Please practice many questions after watching this video to become more comfortable with inequality questions. Thank you for watching. See you again in the next video.